Yeah, so my perspective is more sort of learnings, how it's done at Pfizer. So what you see is a sort of a working example that we have seen at Pfizer, and sort of what I'm going to outline is sort of the steps required to achieve that, right? So I'm going to kind of give you an overview of steps needed to load this SNP data, and show you sort of the reverse engineered data model. So if your data loading was successful, what table should be populated, and how they sort of relate to overall schema, and sort of some of the components involved in data loading. Unlike sort of the clinical and expression data, the SNP data is loaded using loader.jar. It's a Groovy-based code base, and SQL loader, right? So it's external to Pentaho ETL process that you've been hearing so far. A lot of the transformation is done by Perl scripts external to the program. So the step one is very familiar, very common to sort of expression data. You basically have a 8-column mapped subject to sample mapping file. In that, if you're familiar with the sort of ETL data loading for expression data, the capitalized fields are specialized fields. So what happens is during the data loading, those fields get substituted by the code associated with the platforms or the tissue types. The italics are the ones that are optional, and conversely, the sort of the bold regular text are mandatory fields. So if you look at the specific example that I put up there, the platform in the tissue gets substituted by the actual platform used, and the sort of the tissue type that it's referencing. So in step two, while loading the SNP data, really is to load the annotation data. Annotation data is loaded through annotation loader.class file, and the annotation.properties govern the behavior of what that is. So if you looked at the property files, there are certain flags you may set to load it on. Depending on what stage of loading you are at, you may load some of the tables and you may not load the other tables. So if you look at those properties, those govern the behavior of that table. And if this is done successfully, these 4 tables are getting populated. So the color coordination that I put out there will mean something towards the end, but just keep in mind that those indicate different steps and how different tables get populated. In the step 3 is really populating the sample data, and that's done by the loader. And so some of the tables that get populated are in I2B2 schema as well as DF schema. And those are specific tables that get populated when the load happens successfully. Like earlier, like annotation data, SNP properties governs the behavior of loader.class file. And depending on where you're in loading, you may turn on certain flags to load those tables. The 4th step is sort of converting the raw text files into a binary format so that tranSMART can consume it, and this is done for efficiency reasons. And the converter.class file helps you do that. The 5th step is the actual loading the physical SNP data as well as the copy number by chromosome and the probe. In the documentation, I believe it references p-link properties that govern that. But actually, if you look at the code base, really, it's the SNP properties that govern it, the behavior of how p-link loads the data in. A lot of the tables that get loaded are actually not hard-coded, but are referenced within that p-link class. And step 6 is sort of the SQL loader step, where there's a text file that gets read into a temporary table using the control file, and then the SQL will now insert this data set into the actual table. And these SNP calls by GSM. Step 6 and 7 are very similar. In step 7 is the copy number data that gets loaded. Essentially, if all goes well, all of this data set should be loaded, and I have referenced the color that was indicated by the step in this particular data model here. I don't know if it's legible, but I can email you the slide. Essentially, the ones that are grayed out are not directly impacted in terms of loading process, but it is a prerequisite of rendering the data on the user interface. So if you don't have the SNP annotation data in those two gray tables, you may have trouble visualizing the data from the user interface. But essentially, sort of the red indicates sort of the step 2, blue is the step 3, and then the black is the step 5, and then 6 and 7. One of the steps is it's just conversion factor, so that doesn't get impacted. And that's all I have from a sort of SNP data loading process.